Newton's laws. How do we find the velocity, momentum, acceleration, and the force? So this is typical Newton's law. So the question says, due to a force field, a particle of mass 5 units moves along a space curve whose position vector is given as a function of time t by this. So we are given the position vector as a function of time as this. The question says we should find the velocity. So now, solution. For us to find the velocity, we have to consider the position vector. And we are given the position vector as 2t cubed plus t times the I unit vector plus 3t raised to power 4 minus t squared plus 8 times j minus 12t squared k. So now, the velocity is given as this. The velocity equals v. For us to obtain the velocity, we just differentiate the position vector with respect to time. So we have dr dt. Differentiating this with respect to time, with respect to t. So we have, for the height component, we have 6t squared plus 1 into bracket I unit vector. And we differentiate this, we also, with respect to t, we have, this is 12t cubed minus 2t. This will vanish times j. Likewise, this we have 24t. So this is simply our velocity that we are looking for. The second part is the momentum. The momentum is represented as P, which is simply the product of mass times velocity, in which you have m times v. So from the question, we have a mass of 5 units. So we have 5 as the mass times our velocity, what we obtained here. So we have, let me write it here so that it will be clear. So we have 5 times our velocity, which is 6t cubed, 6t squared plus 1, I unit vector plus 12t cubed minus 2t, j unit vector minus 24t k. So we now use our mass to multiply the velocity. So when we do that, we have 30t squared plus 5. Don't forget, it's will be in the bracket form. So we have, when you use 5 to multiply this, we have 60t cubed minus 10t times j. So when you use 5 to multiply this, we have 120t cubed. So this is simply our momentum. The third part is to find our acceleration. And acceleration is given as this. Acceleration is given as small a, in which we are going to differentiate the velocity with respect to time. We have dv dt. So when we differentiate our velocity that we obtain in a, we have differentiating with respect to time. We have derivative of this. We have 6t squared plus 1, I unit vector plus 12t cubed minus 2t, j unit vector minus 24t. This is 2 minus 24t k unit vector. So we now differentiate with respect to time. So the first part is 12t I plus, this is 36t squared. We have 36t square minus 2. We differentiate the last part, we have minus 24k. So our acceleration is therefore 12ti plus 36t square minus 2 times j unit vector minus 24k. So this is simply our acceleration that we are looking for. The last part is to find the force. So we have to find the force here. And from Newton's laws of motion, the force is simply ma, product of mass and times acceleration, mass and acceleration, mass times acceleration. So which is equals to, our mass is given as 5 units from the question. So we have mass of 5 units. We have 5 times the acceleration. We have already obtained our acceleration here. So we write 12ti plus 36t square minus 2 times j unit vector minus 24k. So we now use our mass to multiply the acceleration. So doing that, we have 60ti plus 180t square minus 10 times j unit vector minus 120k. So this is the force we are looking for. So we've completed the solution to the question under Newton's law. So we obtain our mass, our velocity, the momentum, acceleration, and force. Thanks for watching.